This video is about geometric shapes and area. Now, if we get the definition of a shape, we're talking about a 2D contour, and we're not talking about a 3D solid. We're now talking about 3D solid. Some of your common shapes that you may be familiar with, we have a circle and an ellipse. We might think that is an oval, but technically it would be an ellipse, and another common triangle, many other different shapes. If we go to area, our definition of area, we have, it's a little longer. We're talking about the extent or measurement, misspelling there, a measurement of a surface. Now, all shapes have an area because they are enclosed. Let's add that. They're enclosed. So all shapes will have area. Now, what I mean here, so if we go to our circle, our ellipse, and back to our triangle, when I talk about area, I'm talking about the area that I just said in the definition, the extent or the measurement of the shape inside the enclosed portion of the shape. So that is our circle, ellipse, and triangle. We have our shape here and our area here. Our first shape we're going to investigate is the circle. The definition: it is a round plane figure whose boundary consists of points equidistant from the center. So I believe we all know what a circle is. I'm going to try I'm doing this freehand here, pretty close, and actually I don't like that at all. Let's try it again. Yeah, not so good. But if this were my center point, a true circle, every little point that makes up this surface, the boundary, would all be equidistant from the center point. So pretty self-explanatory. The circle is the simplest and strongest of all the shapes. For that reason, it's used in, you can find it within the geometry of many engineered products. For example, just a couple, we have, where are we at here? We have maybe some buttons, a little button there, and maybe even tubes. Now, the tubes would take that circle shape and extrude it, and even within a cup. Now, I guess that actually would be a circle, but from the side here it looks like more of an ellipse. So, and that is a circle. We're next interested in calculating the area of a circle. If you are going to find the area of a circle, you need to be familiar with pi, which is 3.14. Pi is a constant ratio between the diameter of a circle in relation to its circumference. So if we have a circle and the radius is right there, and so our area would be r equals our radius, and pi equals 3.14. The formula for the area of a circle is pi r squared. So let's say that my I'm sorry, let's say that my radius for this circle equals 2. Doesn't really matter to what. And so my area equals 3.14 times 2 squared. So 3.14 times, in this instance, 4. And that is 3.14 times 4 equals my area for this circle with a radius of 2 would equal 12.56. Now let's just say that it was in inches. So that is how we find the area of a circle. Okay, our next shape to investigate is the ellipse. The definition, an ellipse is generated by a point moving in a plane so that the sum of its distance from two other points, the foci, is constant and equal to the major axis. So what does that mean? Alright, so let's say we have, try to freehand this, an ellipse of some sort here. It's supposed to be an ellipse there. And for the widest width, that is our major axis. Alright, and the widest height is our minor axis, or the shorter of the two sides. Now, if I have 2 points here equal distant from the minor axis, these are our focus here. That's our focus. So what that means, and then say if I did a line there and here, this line will be half of the major axis. So let's try this again. So if I come over here and I have my ellipse, try to draw it a little bit better. Okay, you get the idea. And I have my axes here. And let's make them red. Or purple. I have my axis there. And here, the vertical line. Let's come get rid of that. And let's try that again. We have a line here. Alright, let's say that I have my focus here and here. If my entire major axis, if the major axis for me is, let's say 6, any point that I put up here, let's say I put a point here, if I draw a line from that point to one focus into the other, if I add these two up, it would be 6. Let's say that maybe it was something over here, and this could be 1, and that means that this would have to be 5. And as they move along, that makes up our ellipse. So how do we find the area of an ellipse? Well, if this is A, our major axis, and our minor axis was, let's say, 3, I'll make it a round number, let's say it was 4. And so basically half of that is B and the other half is A. So our formula for the area of an ellipse is area equals pi A B. So in this instance, our A, we have pi 3.14, and our A would be 3, and our B would be 2. So our area would be 3.14 times 3 times 2. Our area of this ellipse would equal 18.8